Okay, so I just had to restart this entire lesson because I had to make an edit to an equation later on. So welcome back to me because I've been recording for a while, and welcome to you to this video lesson on solving linear equations. And without further ado, let's get into it. It's going to be a shorter lesson in terms of the content of the lesson, but there is something in the middle of it that you should work on. Okay, so I want to start this with what is a solution? You see the directions in math all the time that say to solve something, and a lot of students go into autopilot, but I want to really pause and discuss what is a solution. So when you are asked to solve something, what exactly are you being asked for? Now, this year I did put a new word in here because we've been talking about sets. So instead of just defining solution, we're going to call it the solution set, meaning we're looking for a set of numbers that are solutions. So what is that? Well, the solution set is the value, okay, and then I'm going to put in parentheses an S. So the value or values of the variable that will make the equation true. Now, I actually could put some more like S's in there, like S's in parentheses. If this were a system of equations, meaning you have more than one equation and you might be dealing with equations that have X's and Y's in them, this definition would still hold. It would just be the values of the variables that make the equations true. But always, 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 when you are solving an equation, this is what you're looking for. You're looking for the numerical values of the variable that will make the equation true. Now, what does it mean for an equation to be true? Just this. A true statement is something like 5 equals 5, or 0 equals 0, or 1/2, we'll make it negative 1/2 equals negative 1/2. Okay, those are all true statements. So when you take the value that you have, you plug it back into the equation. If you get something that looks like that, then that is a solution. A false statement would be something like 0 equals 5 or 4 equals negative 4. Okay, those are not true. Those would be false. So this is what we're looking for, and I want you to hang on to that. Everybody who's had me for Algebra 2, if you ask them what is the solution, they'll be able to spit this back, because we're going to talk about this all year long. It doesn't matter whether we're solving linear equations or quadratic equations or exponential equations or trigonometric equations. It doesn't matter if it's a system of equations or even inequalities. Okay, this is what a solution is. If you see the directions to solve, this is what you're being asked for, which I believe is the next thing that's going to pop up. When we solve an equation, this is what we're trying to find: the value of the variables that make the equation true. Now, when it comes to solving equations, different types of equations have different methods for that algebraic solving, but the end game is always the same. Okay, so if we're solving a linear equation, there's like a way we go about it. If we're solving a quadratic equation, we have certain methods. We factor, use the quadratic formula. If we are solving an exponential equation, we might write each side as a power of the same base or use a logarithm. But we're always looking for the value of the variable that makes the equation true. Always. All right. Now, there are many ways to find a solution without cheating or using AI. So some of you might think, oh, like there's the way the teacher did it and then there's cheating. Not necessarily. Cheating would be taking someone else's work and marketing it as your own, including AI work. But within the fair game of what you can do to solve an equation, you still have some options. Now, the most common is an algebraic manipulation of some sort. And most of you, that when you think of solving an equation, this is probably what you're thinking of. Like the teacher demonstrates, and then you carry out a series of steps to figure out what those variables are. But you can also use graphing. So you can actually solve any equation on planet Earth by graphing. We're actually going to focus on that in this course. We're going to be using Desmos for solving if graphing is on the table, and the often underestimated guess and check. Now, if there's an infinite number of things the solution could be, what are the chances that you're going to guess the right one? Well, pretty small. But sometimes if you can see a pattern in your guesses, you can actually get pretty close or land on the right answer. So guess and check is often underestimated. Always follow the directions with regard to the method you choose. So a lot of times when we teachers are teaching something, we want to establish whether or not you have a particular tool in your toolbox. So can you use graphing? Can you use an algebra solution? If the directions say to solve it and show your work, then probably what is meant by that is algebraic manipulation. We're kind of locking you into a strategy. But regardless of what strategy you're using, always show the reasoning. So don't ever have just numbers appear, even if you're using guess and check. Show what you're guessing, show the check, show what adjustments you're making. Now, for linear equations, the general strategy is to isolate the variable using inverse operations. This means that if you see adding, you're probably going to use subtracting in the solution. If you see multiplying in the problem, you're going to use division in the solution. We'll take a look at that. Now, on the left, I am going to put up on the screen a series of steps that I recommend that you follow for solving a linear equation, but these steps are not in stone. Okay, so this is a good template to follow, but there are exceptions to this. You can go out of order. Just I recommend this because this will work pretty foolproof if you follow it. So first off, if you see distribution, go ahead and do it. There are times when you might want to divide instead of doing the multiplication, but it's a pretty good first step that if you see some distribution, you can go ahead and do it. So I see distribution in two places. The distribution is not the arrows. The arrows are something that teachers put on the screen or on the board so that students can visually follow what we are doing, but they are not part of the distribution. The distribution is the actual multiplication. So the distribution here would give us negative 2x. Now there's two ways of writing this. You're going to do negative 2 times positive 4, which is going to give you a negative 8. So you might retain the plus sign and then write negative 8. Okay, that's one way you could do it. The other way you could do it is instead of plus negative, is you can recognize that adding a negative is the same as subtracting. Either one of those is correct. Use whichever one you are more comfortable with. I'm going to go back to the plus and negative there. Well, you'll see why. Now, we're going to bring down the plus 9. We have not done anything with the plus 9, so we're going to bring it down. And then I have some distribution over here on the right. And this time I have positive 3 times negative 3. This time I'm actually going to write minus 9. But I could also write a plus negative 9 there as well. Does not matter. Okay, now not every problem has distribution. So if you're looking at the problem you're trying to solve and you don't see any distribution, then just like don't do any, you just don't do that step. But it's a good place to start. So if you see distribution, start with it. Now, the next step you see there is if you have any like terms, okay, combine them if they're on the same side of the equal sign. So over here on the left, okay, on the left here, I have a negative 8 plus 9. Those are like terms, and I can combine them, meaning I can do adding or subtracting. Okay. Now on the right, I don't have any like terms. So I have a 3x and I have a 9, but those are not the same. So in my next step, I'm going to bring down the negative 2x, and what I'm going to do is combine these two. So this will be negative 8 plus 9, which will give me a positive 1. And on the right, I'm just going to bring that down. Now, what I'm doing here is a top-down structure. You have to do it this way, not because I'm a jerk and because I don't trust you that you could do it from left to right, but because this is the best way to write it. Okay, and when we get to the end, if I have time, space, and remember, by the time we get to the end, I will show you why. Okay, now after you do that, you should be in a position where you can consolidate the variables on one side of the equal sign. Now, sometimes you will only see an X on the left, or there'll only be an X on the right. But if you have X's on both sides, now is the time when you would want to consolidate them. And you will do that by adding or subtracting X's from both sides, and you will always have an option. Some people always want to get their X's on the left, okay? So if you are of that persuasion and you want to get all of your X's on the left, you'll notice that this is a positive 3X on the right, and you could get there if you subtract 3X, because 3X minus 3X is 0 and will leave you with the negative 9, okay? And what you've got to do is the same thing on both sides. So you will be doing negative 2X minus 3X, which will give you negative 5X. Now, I am not of that persuasion. I don't have to have my X's on the left. I am of the persuasion that I would like to keep my X's positive. I don't really like the idea of doing negative 2X minus 3X gives me negative 5X. Okay, I can do it. I'm just not thrilled with it. So what I'm going to do in this solution here is I am going to take my negative 2X and I'm going to add 2X to both sides. So I'm going to add a 2X right there. Whoops. I thought I turned on my pointer, but I did not. Now I did. Okay, negative 2X plus 2X is 0. These guys cancel each other out, but I want you to really notice why they cancel out, because negative 2X plus 2X is 0. Now, whatever I do to one side of the equal sign, I have to do to the other side, which means I have to add a 2X on this side as well. That is going to leave me with 1 on the left. Bring down the equal sign. 3X plus 2X is 5X, and then I'm going to bring down the minus 9. Now, I just like that better. You're not wrong if you do it the other way. Okay, now we get to the point where undo any adding or subtracting with the inverse operation. So remember this, the goal here is to isolate the variable, okay? And so here's my variable. I've got a minus 9 here, and I can undo subtraction by adding. So I'm going to go ahead and add 9 to both sides. Now, again, we want to remember why it cancels out. Negative 9 plus 9 is 0. Those add up to 0, and that is why they are not there anymore. On the other side, I have 1 plus 9 is 10. I'm going to bring down the equal sign, and I have the 5X. And again, the negative 9 plus 9 is 0. They add to 0. That is why they are gone. And last but not least, undo any multiplication or division with the inverse operation. I have 5 times X, and I can undo 5 times X with division. So we'll divide both sides by 5. 10 divided by 5 is 2. And 5 divided by 5 is 1. So the reason those cancel is because 5 divided by 5 is 1. And then you're left with 1x, which we can just write as x. And there is my solution. Now, there's some flexibility in that. You could, like we showed, get a negative 5x, okay? And then you'd end up with negative 5x equals negative 10. And a negative divided by a negative would give you a positive. I was trying to avoid that. That's why I like this way better, but that other way works. I have seen students move the 1 and the negative 9, so they might subtract 1 from both sides or add 9 to both sides before they deal with the x's. So there is some flexibility. Always, always, always use a top to bottom process. And the reason for that is because you should always see where something came from. So if somebody said, where did your 5x come from? You should be able to look right above where the 5x is to see 3x plus 2x. Okay, if somebody says, where did you get a 1 from? We'll look right above where the 1 is, and you will see the -8 plus 9. If somebody says, where did you get a 10? Look right above where the 10 is, and you can see that came from 1 plus 9. If you are going from left to right, you will not be able to see that visual closeness of the different steps. Okay, so that is pretty much everything. Now what we're going to do, okay, we're going to do some practice. You're going to pause the video and you're going to do some practice on your own. Things to keep in mind as you practice in your notebook, I want you to pay attention to the following questions. How confident are you with distributing? Do you know how to handle it when the variable is on both sides of the equation? So a lot of times students are okay as long as the x is only on one side, but the moment that x is on the both sides, like now we're like, no. Are you making sign errors? That is mistakes when you add, subtract, multiply, or divide with negative numbers, okay? So if all the problems are positive, you'd be like, I am good. But the moment there's negatives, now we're having problems. How often did you need to seek help from a neighbor or the teacher? Now, if you're doing this from home, that's going to be like you don't have me there to help out with that. So I guess you won't pay attention to that. And how many problems were you able to finish in the time provided? So I don't necessarily expect you to finish all of the problems, but I do want you to kind of keep in mind how many were you able to get through. You will not be graded on your practice, okay? You are at no point going to submit this, but you will be asked to provide an honest self-evaluation of how well you did when we're done, okay? So that's why I want you to keep these things in mind. So this is the in-class practice. I want you to complete as many problems. Now, in class, how much time we have to do this is going to depend on how much time we have left in class. My intent is to allow about 20 minutes for the self-evaluation. So that might be, we have 10 minutes to do these problems, 20 minutes to do these problems. If you're doing them from home, I want you to work on these for about 20 minutes, okay? And see how many you can do. Skip around as needed and show your work. Underneath my face down there, okay, the bottom problem reads, you purchase an international phone card for an upcoming trip. The cost of the card is $50 and it will cost you 50 cents per minute to call home. You have a total of $150 allotted for making calls home while abroad. How many minutes will you be able to talk? All right, pause the video, give yourself about 20 minutes and see what you can do. Now, the self-evaluation is going to be found on Teams. So if you're in my class this year, the year I'm recording this is 25, 26. Okay, that's the year that I'm recording this. So go ahead and click on that survey and answer the questions honestly. If you're doing this like 3 weeks after the lesson, I guess skip the self-evaluation. I intend to use it from data. So if you're able to do it like in the right time frame, like go for it. Please do. I want your feedback. Okay, and this is the actual homework practice. So I know there were a lot of in-class practice problems, so the homework is actually a lot shorter. Solve these. You may use AI to check your work and generate questions, but not to actually solve them. So you can pause the video and work these out for your homework. Again, I'm thinking about 20 minutes for your homework. So yeah, let me know how it goes. And you guys know where to find me if you have questions.